I am ADARSH BHOLA, registration number 16BEC1136, and I am going to present this 5, 6, 7, 8 modules of NAND to Tetris software. So the fifth module, which we start after completing our fourth module, which was completion of the software part like the ALU and the RAM simulation. Now we'll start with the building of our hack hardware platform, which is which is which tests the CPU, the RAM, and the ALU part of our code. So, so the result will be a hack machine platform on which we can implement our programs using the hack machine language. So we have to do three tests for it. First one is a memory test, second CPU, and then the third is a computer test. So the memory test all these three tests are done in the hardware simulator, and this is the hardware simulator is only used in this module. So first we have to do this memory test. So I am loading this memory.hdl file in our hdl column in our hardware simulator, and then we have to load the test script of the memory file. So and then we are running. In the screen we can see that it is each and every instruction of the memory file is being compared with the RAM 16 kilobyte RAM which we have specified in our previous slides. So this will run like this. This will take a while, but this will run like this. And as you can see, that while holding the upper case K, you have to enable the virtual keyboard and then press the key for the next message to appear. So we can see that it is showing an equals to message, and when we press the equals to message, it is showing the inverse that is equals to, and when we press the Q, it is showing Q. So we can see that the virtual keyboard on our hack machine platform recognizes our physical keyboard from the laptop, which is the host machine. So we can see that our script terminated successfully and our comparison was successful. So next we are going to implement the CPU part. So after loading the test script and the SDL code of our CPU, we are going to run the script. We can see that it is a long script as it has taken each and every clock cycle into consideration. So we can see that our test script has ended and it is written this comparison ended successfully. So our test script which we had created and our HDL file are correctly matched. So now we have to do it for the computer part. For the computer part, we have written three programs, sample programs. One is the add program, other is the comparison program, like it will compare two numbers and print store the maximum number in a register, and other will print a rectangle of width 16 pixels and length as specified. So in our program we have specified the length as 4 pixels, so it will print a rectangle of 16 cross 4 pixels. So we will be checking directly for the rectangle dot hack. Check. So we can see that it is a long binary code that's hack file. It is actually the assembled code for HDL file. We will be loading the script. Computer. So when we switch our module from view to screen, we can see that a small rectangle will be formed on the top of the screen of width 16 pixels and length will be increasing as the program is running. So this rectangle will grow up to 4 pixels in length. So this rectangle will be growing and this will take quite a time. So we are stopping it here. So hope you understand the concept behind this program. So now we will be moving into another module, which is our module 6. In this module 6, we will be building an assembler. So assembler is a software part, like we write code in high level machine language like C or Java or Python, and that code is converted into machine level language using an assembler. So in this module we are going to build our own assembler, and we have three test programs which are named as add, max, rect, and pong. So these test programs will be passed through our assembler and it will generate a .hack file. Suppose my program name is my program, it will generate a my program.hack file, and the assembler which has been provided by this Nano Tetris software suite will also provide a hack file. So these two hack files should be similar for our assembler to be working properly. So we will test these sample codes one by one. Add.asm file, and it has been divided into two categories, like without symbols and with symbols. Without symbol is a basic version, and with symbols is a advanced version which has a graphical user interface attached with it. So we can see that this add program, it adds up two constants and prints the result or puts the result in the register. Max program, again it will compare two integers, print the maximum. Rectangle program, it will draw a rectangle of 16 pixels wide and are not pixels high. And this pong program, it it is a game, like it is a game in which it is a simple game in which there is a pad and there is a ping pong ball which is always bouncing. So it will bounce off the pad and we have to move the pad using our left and right keys in our physical keyboard. So once the ball touches the pad grows shorter on each touch. So this makes the game a little more challenging. Uh, and so we have to play this game this way, but not to worry, as uh, uh, on further modules this this thing will get easier. So as you can see that we have to first load our source file. Yeah, now I am going to go with this add. So we are in this assembler part. Now we have loaded the source file, which is the add source file, and we have loaded the comparison file. So now when we run the source file, we can see that it is generating the binary code and simultaneously comparing it with the compare file. And now you can see that the comparison had ended successfully. If you want to save this comparison file into a hack file, you can click the save destination file button and do that. So now I am going to do it for the rectangle file. The source file, the hack file, comparison file, and then you have to run it. So when it runs, it checks if every line is equal to that comparison output, like my program dot which you have created using that another assembler, another default assembler of yours, and this is the assembler provided by this NAND software. So again, the comparison has ended successfully, and each and every line matches to the our output. We are going to do it with one more example. This time we are going to do it with the ping pong ball game. And then run this. So when we are running it, you can see that the assembly code is being running and each and every line is again being compared to the comparison. This will take a bit longer as the comparison file is very big. It is about 4 pages. So we will be stopping here. So this was all about the assembler. Now we are going to jump into the next module, which is the VM1, and the edit module, which is the VM2. So the VM1, here we'll be building our virtual machine, in which we'll be putting our assembler, a CPU emulator, or our ALU, RAM, everything. So in this VM module, we have two programs like simple add.vm and simple stack test.vm. We have to check, we have to first put them into a VM emulator uh, that will output a test file named as the program name dot test. So this test file and the compare file, which is already provided, has to be loaded into the CPU emulator, and then if the comparison is ended successfully, that means our VM is running okay. So VM is okay and it is running um, good. It is running good. So we have to do that. And in module 8, we have to complete our VM. Like in this, we have to debug all those errors which you got in the VM1, and we have to full scale it to a VM so that the Pong game and any other games don't hang in this software. So this is it, and thank you.